Okay, greetings everyone. This is the weekly API work group meeting for OPI. Last week, I know there was a really good discussion around the Kubernetes networking infrastructure offload discussions. I think we're going to go ahead and continue that and pick up where we left off. So at this point, Miriam or Donald, whoever wants to take over, continuing on with the slides and the information we were covering. I'll turn it over to you.
Oh, so good to unmute oneself.
I was about to say, I think you're still on mute.
Sorry. Yes, so today we might just carry on the discussion that we from the point where we left off last week. So I might just do a quick recap on what we spoke about, and then we can start talking about some of the resources that we need to share between the tenant cluster and the infrastructure cluster, the appropriate models that can be used to sync that information, and the challenges, I guess, associated with all of those. So last week we kind of spoke about, if we had this simplified scenario where we had a tenant cluster, an infrastructure cluster, we'd install these agents on the DPU side called these XPU controllers. And these XPU controllers would essentially be reading, the incoming resource definitions from the tenant control plane and converting those resource requests to real OPI API calls and servicing, those requests and publishing the results back to the tenant side. The operator piece here was essentially the entity that was going to deploy each of these controllers on the IPU or the DPU, and his role was essentially to sync the resources from the tenant cluster into the infrastructure control plane, the Kube API server here, where each of these controllers is monitoring all of these incoming requests. And then on the host side, what we had was these XPU host controller. Obviously, there's some entity that deploys all of these. It could be an operator, it could be something else. But essentially, these are a daemon set that run on each node on the host side. And the role of these entities is to listen to the CNI running on the host side, as well as what the one other entity called the device plugin. If we recall, the device plugin was the entity that would keep stock of what VFs were available on the host side, advertise those to the Kube API, to Kubernetes, essentially. And essentially, the kubelet would decide which VF it would want to allocate. On the host side, it would request that the DPU, that the device plugin go off and do whatever setup that it needs to do. And essentially, this device plugin and CNI might poke this host controller to create either a new Kubernetes resource request that'll get pushed all the way down to the DPU and get service there, or they may read incoming updates from the DPU side. So I guess the question then becomes, what's the best? So what is some of the information that we need to share first of all? And I guess a non-exhaustive list of resources that we would need to share between the two clusters include the the tenant pod resources, the tenant services, the tenant endpoint slices, as well as the network policy. Now, these four at the bottom here are actually standard Kubernetes resources, and this NetDev CRD, which we spoke about a little bit last week, would essentially be a new type of resource definition. And I guess we might be worried about the scale of how many of these may come into existence, depending on how many VFs are supported on the host side, and that's potentially something that we need to look into. For example, is it best to share, you know, one giant host CRD that has a VF reflected, you know, each VF that's available reflected in that host CRD, and make updates to that, versus, you know, having a separate NetDev CRD per VF on the host. I don't know, has anybody given that any thought, or have we any feedback on that kind of relative level of scale?
Miriam, last week you said something about that there is same scale that already exists on the different devices today. So can you just remind us what device, what object you were talking about?
I don't recall that comment, no. I'll be honest. So this is completely new. And so there's nothing in existence along this path today. And what we were proposing was to have one of these per VF that's available on the host. I guess that means that depends on what your IPU, what the max number of VFs your IPU can service. So
I mean, today, Miriam, though, I mean, I guess equivalent, if we're going with the basic where you have one interface per pod, you would still have a pod CRD for every pod.
Yeah.
So I mean, the numbers in that sense are the same, right?
Yes.
I mean, if we're talking scale, I mean, you're for basically every pod, you would have a CRD for a NetDev. You have an associated NetDev with it. So, you know, there are instances today in Kubernetes where you have like that many instances.
And we need the CRD instead of the usual NetDev because what we want to add special properties that will identify and help us matching it with the physical and virtual functions on the DPU IPU itself.
Yes, as well as allowing the DPU or IPU to do things like allocate the IP address and then reflect it back to the tenant side. So being able to reflect information from the DPU up as well to the tenant cluster. So the CNI, when it plumbs the VF to the pod, knows what IP address to give that VF.
Yeah, it's basically a handshake between code running on the DPU and code running on the host. So whether you're in a one, I mean, I think Miriam was describing a 2 cluster, but I think if you had a 1 cluster, you would still have to handshake that information. Maybe other objects that we get into in the future don't need to be handshake, but at least this NetDev, you're trying to share which VF was chosen and then kind of do the handshake so that the DPU can correlate.
Yeah, just adding just a couple of examples, like you Billy explained, you know, Miriam, that would help a little bit for us to understand. So that's good.
Okay.
Of what are the properties on this new NetDev CRD? And you mentioned the IP address. So you're saying IP address on the DPU IPU side during the handshake?
Yeah. So if you remember last week, if I go on slideshow mode, here it might be a bit easier. When we were talking about the pod getting created on the tenant side, essentially at some point, you know, at some point the kubelet basically says, give me, it says to the device plugin, I want to allocate this VF to the pod. And so the device plugin speaks to that host controller entity that we were looking at a while ago on the host side. And this guy will basically push this NetDev CRD all the way down eventually to the DPU. On the DPU side, you know, it basically identifies the NetDev, so that there's one piece of information for sure. Boris, it identifies the NetDev on the host side and it goes, okay, I need to plumb this guy to my accelerator, but I'd like the OPI API piece to also do the IP allocation, because that can be reflected all the way back to the host, and when the CNI runs, it can just you know, allocate that IP address from the DPU side.
But on the DPU, correct me if I'm wrong, if we, for example, if you're doing OVS on the DPU, right? So basically once we create these virtual functions and we have the NetDev on the DPU side, we need to plug it into a virtual switch itself, that kind of order of operation that we're talking about. So create a device on the DPU side, allocate IP address, plug it into a virtual switch, and then
Yeah.
the operation kind of returns, right?
Yeah.
Okay.
Does that make sense?
Yep, for me, yeah.
Yeah, and then on the host side, it's up to the CNI to plug it into the pod's namespace.
I have one quick question. I mean, so the visual functions will actually be available on the host side, right? So you have the visual function available, the CNI can actually plumb it into the pod. Why do you need this NetDev CRD? I mean, the IP can also be allocated by an IPAM in the host side, like whereabouts, for instance. So why do you need to have this NetDev? What is the actual purpose? This NetDev
So
CRD.
So the first purpose is to be able to reflect to the IPU. So Kubelet up here makes a decision as to which VF or SF it's going to allocate to the pod. And this is on the host side. So the first purpose of the NetDev would be to reflect in a request to the DPU that that exact VF on the host side is the one that I need plumbed on the DPU side. And then, yeah, I guess we could have separate IPAM here, but it would create a bit of confusion, I think, if we were just generating random IP addresses on the host side that didn't really match, what was going on the DPU side, and it would create some added complexity of having to map IP addresses from the host side onto the DPU, I think anyways.
Yeah, another way of thinking about it is that if you're doing the full like networking infrastructure offload to the DPU, then the IPAM and IP allocation decision should be happening down as part of that network infrastructure offload. So actually at that point, the only thing that happens on the host side is the CNI choosing a VF to plumb into the pod and then actually putting it into the pod's namespace, and everything else you want to happen on the other end of the VF on the DPU side.
So one of the other way to look at this is because some of the policies in terms of how IP address assigning happens is more of a tenant functionality as well, because they want to pick up what IP address ranges they want to work with. So if we move that to DPU, then the DPU and the tenant policies would not match up. If IPAM is completely not managed by DPU and it's managed by, say, whatever implementation, IPAM implementation on host is, then it's a cleaner implementation. Anybody can change the IPAM policy and get a new IP range based on whatever they want.
Yeah, I think it's fair to say that it would be reasonable to want to be able to do the IPAM on either side, or on the guest or host, or on the DPU. And one of the purposes of the NetDev needs to be able to support the IP allocation on either side.
And question from the PCI Express side, guys, just to make sure I understand. From the PCI Express side, when we choose the virtual functions, let's say, right, that choice obviously happens on the host. We create the virtual functions, then the enumeration also happens on the host, and BDF is assigned on the host itself. So we need that information as well to be part of CRD in order to say, okay, this is the enumeration and this is a BDF of this virtual function, to communicate it back to the DPU, so DPU can know what BDF was assigned to the host. Otherwise, DPU is completely unaware. You cannot get this information in any other way from the DPU itself, right?
That sounds right. I'm trying to understand your wording.
Basically, in Linux, if you create the virtual functions, right? So
Mhm.
you do in the echo in the sysfs, the virtual functions pops up. Immediately happens a hot plug, the enumeration, BDF is getting assigned to this virtual functions. So the address of this physical function or virtual function is on the host. The DPU is not aware, it only knows the numbers, right? It doesn't know the BDF address on the PCI Express bus of the host. It only knows like this is virtual functions number 20 of that physical function. So the numbering on the DPU and the addressing on the PCI Express bus are not matching.
Yeah, but I'm not sure if this CRD is going to do that, but it will tell you which of the ones have been chosen. I'm not sure if it was going to do the full. Or maybe it can. I don't know if that's the right spot. Maybe it is. I would have to defer to someone else there.
No, but what you're saying that some information is going to be communicated via the CRD to the DPU. What information you're talking about, right? Is it a number of virtual function or is it the BDF address, the PCI Express address of the virtual function?
Yeah, so last week we were saying that we needed to decide what that information was from the lifecycle group. So we'd spoken about maybe, you know, the serial number of the serial number plus the PF plus the VF that was generated, VF IDs that were all generated, or some combination of unique information to identify the VF. But as I recall, you know, last week we were saying that that was something that was already kind of being discussed in the lifecycle group and would be finalized really there.
Okay.
Yeah.
Yeah, and so one other point, because we were talking about IP address before, is we have a bit of a sequencing going on here. So the device plugin and kubelet deciding which VF is chosen is done up front. And typically, once that's been made, then the CNI will get called. And as part of the CNI is part of the IPAM, typically. And so we did move the IPAM in this sequence diagram down to the DPU. But if we were to, you know, I think Donald had mentioned we need to make this flexible so that it can be passed either from the host or from the DPU, that it would be the initial creation of the CRD of which of the VFs was chosen would be, let's just stay in the device plugin step. And then later, in a later step, when the CNI gets called, if we move the IP down there, there would have to be either another CRD or another way to update the CRD to reflect the IP because it's in a later step. Does that make sense?
Yes, it does.
And so I'm not saying that we shouldn't do it. We you know, that's part of bringing this up is, you know, we wanted to get some of these issues down just so we could talk about them. So and if we think that the IPAM needs to be done at the CNI, that would be after the device plugin has already handshake the NetDev down to the DPU. Then we'd have the IP allocation, and then that would have to get synced at another sync, whether it's the same CRD or separate, but it would have to be a second step in that chain to get that sync of the IP back down to the DPU.
I think we have to do it in two separate steps, whether they are, you know, combined to a single step like you shown on this diagram, or is completely a separate step, but at least it have to be two separate APIs so we can have a flexibility to move both of them.
Yeah, I think what we were thinking in the CRD was that you know, if you look at standard CRDs, you have like a spec, which would have the VF information in it, and then a status field that the DPU would update with the IP. And then we could put the still have the IP in the status, but it would be now written at the guest level, at the host.
I think the infrastructure side needs to manage the mapping, the IP and the MAC address, and needs to be propagated to all the VTEPs so that it can be routed And if infrastructure side assigned IP address, it may choose to keep the static assignment of the IP to the MAC so that the mapping table doesn't have to be updated every time the port is deployed. So that kind of arrangement is possible if DPU side has IP assignment. And it also the user's intent, but user may provide intent for the CIDR block. This is a CIDR block. I want to see the IP address assignment. And that can be propagated to the DPU side. And then DPU side can set up the IP address and MAC address, then it may choose to keep it static.
Yeah, I don't disagree that the, like the subnet that the IP would be chosen from should be provisioned from the host at some point in the sequence.
Yeah. I mean, that could be potentially the separate CRD step that or I don't know. Yeah, I mean, it could, yeah. See, the CNI would have the CIDR information, right? So it could either poke the host controller to update the CRD status, and maybe the agent controller is watching, the status field in the same NetDev CRD, and then he goes, it could have information like CIDR information as well. And then, at this point here, we'd have a sequence of calls that would go all the way down to the OPI API to get the IP address. I mean, we could play around with that. I could mock up something like that and see what that looks like for sure. It's not a big ask.
Yeah, at least we need to allow the DPU to do the app suppression with those kind of optimization. And
yeah.
So I have another question on this slide. And on the right side, you show the XPU agent itself, which is OPI XPU controller, right? So this controller implements what? gRPC APIs. So this notify NetDev CRD, and then the reply update status IP address. This is all gRPC APIs here in the middle.
Yeah, they're all standard Cube APIs where we're watching resources that generally work over gRPC. Yeah.
So the question is, do we need an OPI API to the right, or OPI XPU controller is what we do with OPI APIs? In that way, every DPU vendor can implement its version of OPI XPU controller by itself, and has this creation of NetDevs and all of that IP stuff, that all the communication that you've shown here in OPI API in completely proprietary way. And in that way, we standardize the OPI APIs on the OPI XPU controller APIs instead of doing, this kind of separation. I'm just brainstorming, I'm asking.
It could be possible. I mean, this could be, so this is just the pod that's running on the DPU. There's no, and this is one container in that pod. There's no reason why you couldn't expand, that blue box to include the OPI API like that. And this could be running in a separate container and potentially have, vendor specific logic running there.
That's my thought exactly. If we can, I'm just trying to think what OPI as a community produces as a source code, for example, right? So we can produce a container image, which is vendor specific one, and it can run as a side container inside the pod. And then you will choose which side container to kind of attach according to what vendor you're working with. But this entire implementation of the OPI XPU controller sidecar is completely vendor implementation and not generic implementation. And then we have a moving left the OPI API instead of having very granular kind of thing. I'm just thinking out loud.
one comment on that, Boris. I mean, unless I misunderstood. So if you move that controller out of the DPU, then the DPU by itself is no longer supporting the OPI, right? Or doesn't have a requirement to support OPI. You could do, and if it's vendor specific, I could do what I want. Or did I misunderstand what you said?
I'm not saying move controller out of DPU. What I'm saying is APIs as this XPU controller exposes to the infrastructure cluster. Basically, on this picture, we're showing only one gRPC call here, the notify netdev CRD, if I understand correctly, right? So what I'm saying, if in Kubernetes workstream, if we define that this is OPI APIs, and we standardize on those calls instead of all these low-level operations like create netdev and get IP and stuff like that.
Okay, so you are saying that the OPI can move upwards for this.
Yes, OPI dotted line can move left and be combined with a blue OPI XPU controller.
Yeah, it's interesting. I mean, I more envisaged, and please correct me if I'm wrong here, folks. So, so everything to the left here, this is just standard Kube APIs. Just ignore this piece, okay? So this is where, excuse me. Just to the right here of the XPU controllers is where I had envisaged like OPI API calls, and potentially what I thought could be produced as you know, reusable entities was definitely this XPU agent. Potentially we could expand the pod to include the OPI API here, but this would all be relatively generic. So it wasn't vendor specific. Everything that happened beyond that, you know, to the right of this box here would be vendor specific.
Yeah, I understand. The proposal is good. I'm just trying to kind of come with an alternative, because if we think about gRPC calls, basically in this picture, you introduce 2 or 3 layers of indirection, right? The first gRPC call comes from the Kube API server to the OPI XPU controller, okay?
Yeah.
Then the second gRPC is inside the DPU itself, right? Between the agent, the OPI XPU controller, and OPI API, because OPI API currently, if I'm, you know, following what we're doing so far, is also gRPC call. And then this gRPC call from OPI API, so we need some entity to listen to the gRPC endpoint in OPI API and translating it to actual vendor SDK implementation. And if it's, I don't know, Linux kernel implementation, let's say, so this is kind of shell command or, you know, sysfs, whatever we have, the standard IP stuff, right? So I'm just wondering if we need this 2 level of indirection and 2 entities running alongside each other and communicating over gRPC inside, like between 2 containers inside the same DPU, or, you know, or we don't. I'm just, you know, asking.
I think you need this OPI XPU controller because this is the only component that actually understands how Kubernetes API server works and what a CRD is, and then translate the information from the netdev CRD to the gRPC calls towards the OPI API. So you need that controller that actually does that translation. At least this is my understanding on what I'm seeing right now.
I'm not saying remove the controller. Controller is absolutely available. What I'm asking, if we need to implement this controller in a vendor agnostic way and then translate it to OPI API, or each vendor can implement its own OPI XPU controller with the standard netdev CRDs and whatever the standard Kubernetes APIs, but then instead of translating it to OPI API, it will translate it directly to their SDK.
I think it's, sorry, Boris, I think it's desirable to keep the Kubernetes abstraction, i.e. the CRD, decoupled from the OPI API, so that the Kubernetes networking and other infra can evolve independently of OPI. And we want OPI's API to be be stable across different consumer use cases such as OpenStack, as well as container workloads, etc. So it seems like I hear your point that there's additional layers of indirection of gRPC calls here, but I think the separation is desirable to keep, but there may be other ways of achieving that separation, but not having gRPC APIs in between.
I hear you. I'm not against it. I'm just saying out loud that this is a two indirection thing, and to the right of OPI API, we have another call to vendor SDK, and we just need to acknowledge that.
Yep, agreed.
I mean, if we make it non-Kubernetes, don't you still have one more indirection, Boris? I mean, from Kubernetes to OPI anyways. I mean, we still cannot avoid that indirection, right? You still need the two. I don't see how we are saving. So this is Kubernetes specific. It doesn't say it. It just says OPI XPU controller. It's literally Kubernetes OPI XPU controller, right? It's not going to work with something different than Kubernetes.
Yeah, the OPI XPU controller's role is to mediate from the kube specific resources such as the NetDev CRD to whatever OPI API calls are used to implement what the NetDev CRD is asking for. So it's the explicit kube specific indirection, if you will.
Correct. So that means if I hear what Boris is saying, if we left shift that as OPI, it'll still work only with Kubernetes, right? It won't work. If you need to work with something else, then either you're changing your OPI API or you need a translation again.
Yes, you'd be choosing to bake Kubernetes specifics into the OPI API.
Correct. Yep. So is that what you're suggesting, Boris, or?
Yeah, again, this is just additional API. We can, as gRPC, create another service that is specific Kubernetes, and then you have all the rest, which is cloud native or whatever you have for networking. I'm not saying I agree with Donald and others on the separation. I'm just calling it out loud that if it's a pod running inside your DPU, then you have a couple of side containers here. One is implementing the controller. One is implementing the OPI API gRPC server that translate those OPI API calls to your specific SDK, Marvell in your case, Prasanth.
Yeah, but the thing with the latter would, maybe I'm puzzled. So ultimately, what you're calling OPI is still Kubernetes specific, right? I mean, it's not something that is, I mean, there's nothing OPI about it. What is OPI about that API? It's just Kubernetes.
No, no, the OPI part is the NetDev CRD, right? The NetDev CRD that we agree upon, this is the OPI, right? The gRPC call to notify about NetDev CRD, this is something that doesn't exist today. But yeah, when we started the networking discussion, we said that maybe we need to create a separate network APIs, one for Kubernetes specific one and one for cloud infrastructure, different one. And this is why I'm just asking that maybe we end up with those things. If we can do this kind of separation of two layers, then yeah, maybe we can reuse OPI API in different other environments, not just for Kubernetes. I'm just wondering, that's all. Thanks.
Yeah, no, I think with what you just said, I think, yeah, I also think if you want more adoption of another DPU vendor who cannot support the lower level OPI API, but they are more amenable to integration into a Kubernetes environment. So maybe that direction does make sense.
Yeah, basically, if you want the vendor itself from the DPU to go and implement its own OPI XPU controller, right? We don't want to prevent them from doing that. But what is the standard? If we standardize on this new NetDev CRD, for example, right, and say, okay, if you want and implement your own OPI XPU controller because you have additional value that you can add by a vendor, you can do it in a better way or whatever, then you have to implement this kind of NetDev CRD. So the specification kind of moves into that direction. Okay, we want to standardize between the blue and the orange.
I get your point. Yeah, thanks.
Yeah, and it makes sense because the protobuffs and whatever being exchanged is this at this interface level, if they are standardized, then the API and the data types are standardized. After that, everything can be vendor specified, depending on the DPU vendor.
Okay, didn't want to derail, Miriam, please continue.
That's okay. So it's an interesting conversation. Yeah, I mean, we can draw a few options and see what that kind of looks like. It would be interesting even just to see it, you know.
I also got
So-
questions from our internal Kubernetes teams about a little bit more about the roles of the XPU device plugin on the left versus the XPU host agent. So again, this diagram kind of shows a little bit of that, but maybe we can just double click on this.
Yeah, so the construct of a device plugin in Kubernetes is something that would create a resource pool of a particular resource and then advertise it to the kubelet. So in our case, this XPU device plugin is essentially scanning the host system to understand, you know, what VFs are available on the host. It creates then a pool that it advertises back to the kubelet, and then kubelet knows that when it wants to allocate a pod that wants to leverage, you know, DPU networking, then it can take a VF from that specific pool. The other kind of major thing that the device plugin has in terms of, you know, it has hooks directly into the kubelet itself at pod creation time, which gives us the opportunity to intercept when a pod is going to be created and do whatever we need to do to initialize a VF or, you know, gather whatever information that we need to about a VF and, you know, complete that before the pod actually gets started. So he's kind of like a VF management entity on the host.
So two questions here. First of all, if some DPUs don't support hot plug, can this device plugin like immediately you know, scan all the, you know, existing functions and have, okay, this is a pool that presented to you. You cannot hot plug anything, but this is a pool that, you know, statically allocated for you. Probably yes, right?
Yeah, you can configure stuff like that as a sysadmin. You can decide, you can make decisions like that. You can create separate pools of VFs, and you can probably, you know, specify specific behaviors for each pool for sure. You can do that even today with some of, so I work on a slightly different project that uses AFXDP, but you can create basically resource pools that either are tied to a driver or a different field that you specify. But all of that is just things that you build into the device plugin itself.
And the second question that came up is how it's different from all the existing SROV infrastructure, because they also deal with the same virtual function, physical function, and SROV.
Yeah, so this could be the SROV device plugin. Now, as far as I know, SROV device plugin right now doesn't support sub-functions. It's kind of a work in progress. So I guess, you know, that's behavior that would need to be added in to the SROV device plugin that exists today. The other thing, obviously, if we introduce these CRDs, then that's behavior that also needs to be added to the existing SROV device plugin. So this is
That makes a lot of sense. And if you, on this blue kind of XPU device plugin, if that's possible in parentheses or something like that, that say that optionally, or SRV device plugin, replacement, enhancement, whatever, I think that will help a lot to clarify what we're talking about here, I think.
Yeah, no problem.
Thank you.
Yeah, I mean, there's a lot of overlap there. And then like Miriam said, the two big changes would be the sub function or any additional type of virtual function that is different than what SRV supports today. And then the whole management of the CRD, the hooks to allow that to happen.
No, that makes perfect sense. Mhm. And you envision that, if possible, to enhance the existing SRV with all functionality that we want, that's fine. If not, this is something to be created as part of OPI.
Yeah, I mean, you could always take SROV as a base and just add what you need on top of it. But obviously, if you can reuse the existing project and push changes up to it, it's always better because it already has an established set of users and all of that good stuff, and people know where to go for that device plugin, and that's always a little bit easier to consume from an open source point of view and reuse.
Yeah,
Yeah.
so I was part of that. They're part of the network plumbing working group, and I've been involved with them in the past. We'll just have to see if this is too big a change for them, or they would recommend a different device plugin for it. We'd have to work that community and decide if they wanted this type of functionality in there or not.
Yeah, so if they accept, that's obvious. If they don't accept, you envision us to host it on our GitHub and kind of co-develop it as a community, right?
Yes.
Yeah.
Okay. No, just making sure. Thanks.
So Boris, just to add to that, we took that path of putting SRIOV and sub-functions together. So we created two separate backends behind this device plugin. One is for sub-functions and other is for SRIOV. So it seems to work as a unified device plugin, but yes, it's not open source yet.
Where is that, Nupur?
This is something that's not pushed to IPDK yet, but the plan was to push it to IPDK. I have to work it out with Dan to see if we can.
Oh, so it's Intel part of IPDK. Okay, just
Right. Yes.
Thanks. Mhm.
Okay, so that was taking adding sub functions to SRV device plugin. Is that what you're saying?
Yeah, it's a combined device plugin that takes in a configuration for the flavor. It's gonna come up as, so you can configure it for SRIOV, or you can configure it for sub-function, dynamic sub-functions, and then it behaves accordingly. So it's integrated device plugin.
Great. Well, it will be nice to see it, Nupur, once it's ready and pushed. And I agree with Billy. If you can push it into the SRV device plugin open source, that will be beneficial. If they will not accept it, obviously, the path is to keep it in OPI.
Yeah, definitely we can try first attempt at IPDK and then convince the community if they were to accept that. We have to see how it goes. And if the community accepts it, we can integrate it together into one.
Yeah, anyway, if we want to keep it in OPI, Nupur, that at some moment we want to review it and move it into the OPI GitHub organization from the IPDK.
That makes sense, yes. Yeah.
Okay. Okay, so I at least for me, I identify already two kind of open source project that potential can be done in OPI. This is what I wanted to ask today, is the XPU controller on the right side and the device plugin on the left side. And there is also the host agent, which we didn't discuss it, right?
Yeah, but I mean, like, this could potentially be code-wise the same thing that just gets configured with a flag, so it could be the same project, just a flag that says, deploy this in host mode or deploy this in DPU mode.
Yeah, absolutely.
So we actually only kind of looked at the NetDev CRD, but today, but there's lots of other things that we need to consider. Like, for example, like the pod resources, that's a standard kube resource that gets created on the tenant side, and it'll get pushed to the kube API server on the tenant side, when somebody creates a pod or whatever. And this operator piece in the infrastructure control plane, he's going to have a pretty important role, because essentially, a lot of these resources get created within the standard kube namespace, which is kube system. So we want to avoid a lot of confusion when these resources get pushed to the local kube API server on the infrastructure side. So that, I guess other entities, other Kubernetes entities running on nodes and so on, don't get confused and try to, for example, Kubelet could try to deploy a pod spec that came all the way from here, which is going to be problematic. So the operator could have a role in either normalizing, serializing the incoming resources to potentially a separate namespace, so that, the existing Kubernetes entities and the infra node don't get confused. Or, of course, the other option is to create a CRD per resource on this level. But honestly, like, a CRD at that point doesn't really make sense, because the spec will almost look the same, except that, it'll be, maybe named slightly differently. So I guess, have you guys looked at this from the IPDK side even? Maybe Nupur, how to synchronize pod resources down to the infra side, so that the existing Kubernetes entities don't get confused by what's going on?
Yeah.
Or do you have something that?
Right, we have some code checked in into IPDK already around this thing. So whatever resources are coming from Kubernetes side, we created our own this gRPC messages, as you mentioned, right? Our own APIs here between for the agent to what we call it as infra manager, which is the XPU agent, to keep the separation out, to see what resources we are concerned with, and not to confuse Kubernetes resources with our resources.
So was the infra agent directly connected to this kube API server on the tenant side, or?
So we created what is called a host agent, and then created what is the DPU agent, right?
Yes.
The separation. And the host agent is the one that's actually talking with kube APIs, right? That's the guy integrated with kube APIs. And the DPU agent and host agent, the APIs are completely separate. Host agents is aware of all Kubernetes resources. It's aware because it's implementing the kube APIs. But infra agent, or we call as infra manager, like the DPU agent, is only aware of what it needs from DPU networking perspective.
Okay, so some translation happens at this level.
Right. Exactly. At this level, to create this separation out completely between Kubernetes resources versus what are XPU resources.
Yeah.
Man, I don't think they have Kubernetes running down on the DPU either. So they're translating and then just sending protobus down to do the provisioning.
Yeah. Yeah. It's interesting because that would be the CRD kind of model, a separate CRD where you translate or pull out the information that you need from the existing resources and
Mhm.
reflect them down to the infra side. Which I think would be a level of duplication of information for us if we were to follow a CRD, a pure CRD type model.
Yeah, I really like your suggestion, Miriam, with operator being normalization for a different namespace. I think that's really neat idea. If we can pull it off.
If we can pull it off, we just have to talk it, see how it pans out. Yes. Okay. And so, like, one other question that people might have potentially is, you know, like myself and Donald and Billy have spoken about this, which is, do we really need this operator? Is it okay to connect each of these agents to the Kube API server directly? You know, but we were kind of worried about the scale of connections on this side and having to reflect information, you know, n times to n agents, and that's potentially why we thought the operator would be a good entity to have as a man in the middle. But we'd love to hear if anybody has any additional feedback on that.
What is the second option again? Not having the operator on the infrastructure control plane is connecting?
Yeah, so essentially, sorry, I hate changing lines. So basically each one of these guys would have.
Oh, that I understand, but who will do all the translation from the namespaces?
They'll have to do it separately, individually.
Oh, okay. No, I was just wondering if you want to move the operator, the new operator in the tenant control plane, or completely eliminate the operator and connect directly.
Yeah.
Yeah, I
The
think
other,
those are the two models she was saying. Either we have each of the controllers listening to the other API server, or we have this operator, this kind of, like she said, the man in the middle type, you know, doing the proxy for it.
And the operator can be either inside the infrastructure control plane or in the tenant control plane as well, right?
yeah, it could. It could. I mean, it could. I think it makes more sense to keep it in the infrastructure side at this point because I see it as an infrastructure component somewhat that's talking to the Kube API server here. So essentially, rather than, you know, like leaving every tenant have a component that's talking to the infrastructure control plane, I think it's better to have the infrastructure entity being able to talk to each tenant control plane, if that makes sense. So I don't want to give access to an entity on this side to infrastructure resources or infrastructure capabilities. But what I want to keep is the ability to get information from the tenant side through an entity that lives on the infra.
Otherwise, you can breach the trust domain, right?
Yes.
Mhm.
So if we wanted to go way down the trust rabbit hole, we did think about potentially having a separate entity called a broker. But this is actually quite complex. So typically what you would have then is a third. So we're always talking about a 2-cluster scenario, a tenant cluster and an infrastructure cluster in the diagrams I've drawn out. What this means is, you know, adding an additional separate cluster that both the tenant, you know, the tenant side and the infrastructure side have access to. And essentially all this is a data store of CRDs or resources, but it gets quite complex pretty quickly, and it introduces even another layer of indirection, you know. And when you talk about the scale of the number of things that needs to be transferred from here to here to here and so on, it gets relatively scary. So we'd have concerns about, I guess, latency. You know, what would this additional hop introduce in the picture, and just generally, you know, is that latency worth having an additional cluster with all the deployment challenges that would bring, you know, yet another cluster to maintain?
Yeah, but it's a very interesting idea. For sure.
Is this
Um,
operator OPI specific, or it's somewhat neutral that way?
So it would be OPI specific in that it's deploying each of these XPU controllers on the DPU side, and it's actually doing translation of resource or serialization of incoming resources from the tenant side to the infrastructure control plane. So I think it will be OPI specific.
One quick question. What will be the problem if we have those pink boxes, the XPU controller directly listening to Kube API server that runs on the tenant side? What do you see as a problem?
So the tenant side would have to notify each one of these guys individually of the resources, of changes to each of the resources they're monitoring. So instead of sending, you know, one notification to an operator that's monitoring the pod resources, I now send out 4. And
Should they send the notification, or the XPU controller can just listen to specific events?
So even if you're listening to specific events, I mean, you're listening to events for pods, services, endpoint slices. These are things that have a high frequency of modification and creation within the context of a cluster. So I would be, I mean, it would be interesting to do some benchmarking for sure, but I would be worried that when you scale this out to a significant number of nodes, the load on the Kube API server, which is already, you know, loaded, could introduce a significant delay and performance issue.
But you also have a security boundary to think about there too. Between this tenant and the infrastructure, right?
Well, I mean, I think the infrastructure could listen to the tenant, but the tenant couldn't listen to the infrastructure. So
Yeah.
I'm not sure if that security issue is there.
Well, you could have an attack, you would have an attack zone, right, at that particular point where a tenant could attack to get to the infrastructure.
But if you are just listener and you just read from the tenant side, you can take decisions after. When you read something from the tenant side, you can take decision to be sure if you are gonna implement what you are listening or not. So how this attack can actually be generated if you're just listening for events? The tenant will not have any direct communication with the infrastructure. The infrastructure will just listen for events.
Right.
I don't see how you get like security breaches this way.
In order to listen to events, Dimitrios, you need to exchange keys, right? Certificates, SSL.
Yeah, you have to open up some level of communication. So once you do that, you open a boundary.
Yeah, but you're listening to the control plane.
Right.
So
It's just something to consider.
no, you're right. It is.
Yeah.
It is. But back to the question of why can't the XPU controllers just listen to the Kube API server? And I think you could. I think, you know, like Miriam said, there's a lot you'll be listening to, but now the question is, do the purple boxes on the host, are they listening for those as well? Or because the deep XPU controller is doing that, the host no longer needs to listen to those. So, you know, maybe maybe it's an even swap or maybe it's double. I think it would have to depend on what's listening on the host. And did you just double it, or do you not now listen on the host? So now you just moved who's listening. That would be the question, I guess.
And we can do it in 2 steps, right, Billy? The simplest thing to implement and to actually POC is to direct listen to the Cube API server, right? Without the operator. So we can start there and then move to the operator model as we, test it and see how it goes.
Yeah.
Yes, potentially. I mean, depending on how far down you go, you don't want to go too far. Like we've already done all this work. We don't want to add the operator now, but yeah, it would just we'd have to see how much that changed it, whether the purple boxes are no longer needing to listen to those resources. So you've just moved who's listening, or whether you've doubled it, you've duplicated how many are listening. I don't know if I can answer that yet.
That's an interesting one, Billy. Like we could just to think about it for a second, we could draw it out and see what it looks like. Which is, we could do something where yeah, so we could do something whereby essentially the device plugin creates the NetDev CRD rather than the host controller, and then he pushes that to the Cube API, and basically that gets pushed down to the XPU agent, the infra agent, essentially getting rid of the host agent. The only thing that it means is that every time the CNI runs, it would need to talk to the Cube API server to get the IP address, or we might have to figure out something along those lines,
Yeah, but I
so
think
the reason-
CNIs in general will talk to the Cube API server though, won't they?
If you have a stateful control plane piece, for sure, yeah.
Oh yeah,
So,
yeah, that's true.
yeah.
That's true. Yeah.
No, many CNIs they do not speak to the Cube API server. They're just dumb.
Yeah, you're
Yeah,
right.
binaries. Yeah. Like the only. Yeah, go ahead. Sorry, Miriam.
I was just going to say, let's have a think about it and let's see if there's a model that we can come up with where this guy could potentially monitor the Cube API server directly, and potentially we could eliminate one entity on the host. Let's have a good think about it and see if we can come up with something around that.
Okay. All right.
Yeah, I think it's desirable to support multiple setups. The customer may have very small setups, and which probably doesn't require 2 separate API server for the scalabilities. But for the large deployment, it may be necessary. And I think also Calico has a Typha, which actually works in front of the API server for the scalabilities. It's probably good to look at the Calico's approach for the Typha.
Okay, well, we can pick this up next week. We've reached the top. Well, actually, we're actually over our time frame. We're already dropping people, so we'll pick it up next week and continue from there. It's been a good discussion. Thanks, Miriam.
Thanks, guys. Thanks, Billy and Donald as well.
No, thank you.